So happy to be joining you today, and I have the easy job since I'm the moderator. My name is David Cass. I'm the global CISO for GSR.io. We're a crypto market maker. Before that, I was a federal appointee to the Federal Reserve for large institution supervision. So I'm happy to be joined by esteemed colleagues today. So I'll let them briefly introduce themselves, and then we'll get kicked off talking about governance, security, and privacy for blockchain and crypto. So please.
All right, thank you. My name is Shumo Chu. I'm the founder of the Manta network. This is the right place. So, we're doing on-chain privacy for Web3. Basically, we privatize all the assets. We privatize voting. We privatize all the DApp, right? So, yeah, that's about me. Yeah.
Hi, I'm Nikki Robinson. I'm back. I was here a little while ago. Still a security architect, still a professor.
Awesome. I'm Ayush Khandelwal. I work as a software engineer at Google on infrastructure security, so protecting the data centers, servers, all that stuff.
All right, so we'll start out with an easy one and go for, based on your experience, how does governance change when implementing blockchain? What are some of the fundamental differences?
All right, so we have on-chain governance, which is decisions that are made on the protocol, and then we have stuff like off-chain governance, where people use stuff like social media and Twitter to figure out what decisions have to be made. There are pros and cons to both of these things. I think Hyperledger Fabric has an open protocol, which they use for governance, but yeah, they have their own benefits and disadvantages. I'm a big fan of how DAOs are trying to operate now, which are decentralized autonomous organizations, where members who own a certain coin can make decisions. And it's easy for people who have a certain coin to have voting rights, and this can be easily defined on-chain using code and stuff. So I'm a big fan of on-chain. There are pros and cons, but yeah.
Nikki.
Yeah, so I think governance really changes in this space because when we start talking about decentralized assets and areas, it sort of becomes what does governance mean to me? So it may be different depending on where you're at and even depending on where you're at in the sector, right? If you're adopting blockchain or blockchain technologies, or if you're building it, governance may mean something different to you. So I think this sort of need for like a universal taxonomy or something like that, some way that governance sort of applies across the entire industry, I think is going to be really important.
Right. Yeah, I think like all these views, I just want to say something more concrete, kind of because we're doing a Web3 like enterprise, kind of sleep on the street, right? So see all the governance decisions happens. I think there are two like significant point of decentralized government. It seems, at least in my view, has an advantage, right? I think first is that, let's say, like you are a big enterprise, right? All these kind of important governance decisions made in the board meetings, right? Or then there are some kind of like if it's a public company, you have the stockholders meetings, but this is a kind of more indirect. And if you're doing on-chain governments, right, every token holders will express their vote, and this voting is immediate, right? So then that's kind of like like getting rid of some frictions of direct participation of the token holders in terms of governments. And secondly, right, I think it can be happens more frequently. Because no matter you are talking about governance, democratic systems, like organizing and voting takes a lot of time, right? And the blockchain allows you to put in vote on-chain. So these government decisions could be made more quickly. So for example, we do a Twitter space and do a Discord discussion, then move on-chain to the voting. And this decision-making can be made more quickly. And that's actually solving a lot of problems of the democratic systems. You do want to move in quickly. At the same time, you want to like broader participation of the government decision, right? That's basically my view. Yeah.
Yeah, those are great points. So kind of building off of that, when you start thinking about a lot more implementation is happening in the kind of private blockchain space. So as organizations adopt more private blockchains, so what are the key enablers to kind of assure that there's a secure and private chain that they implement?
So obviously, if centralized blockchains are really useful in places where you're working with a bunch of companies and you want to have some consensus present. So it's useful in places like logistics, for instance, where you have a lot of parties operating and you want to have the benefits of blockchain. But centralized blockchains also operate a lot like a distributed database, right? So there are distinctions which need to be present, which make the use case worth everyone's time. I think one of my favorite projects is Hedera Hashgraph, which is, it's kind of a centralized blockchain, and it uses this thing called Gossip Protocol, which basically is a faster way to communicate. So one thing private blockchains give us is incredible speed and scalability. Since they are centralized, and if there are limited parties which need to exist to make consensus happen, we can get incredible speed. And that's where I feel like private blockchains can really benefit and provide value and be more than just public blockchains, right?
Nikki.
Yeah, so when I think about how do you actually do this securely, I think about all of the common types of cyber attacks that are happening right now that we still can't get a handle on, like phishing, things like that. It's really just being adapted for this space. And so I think really being prepared for those types of threats and what it might mean to your organization, like ice phishing that's happening now. They're talking about, basically someone comes in and they get you to basically hand over your assets to them, and they're like, oh, well, they're going to take this and take care of it. No, they're just going to take it. So I think understanding those types of threats, threat modeling is really important, specifically in your space, because it's going to be different depending on the organization that's adopting it. So threat modeling, I think, is going to be really important.
Right. I think I'm not a super expert in the private blockchain space. I do think, right, so for example, in the privacy blockchain space, because it's kind of like more like a permission model, so a lot of threat models, a lot of like techniques you make a private blockchain more secure, like could learn some lessons from existing like infrastructures, like the things like Google, IBM, Facebook they're building, right? So it's kind of like a more close to the Web2 security model. But in the permissionless blockchain, like a public blockchain, there is some new kind of attacks that in the private like blockchain space you don't have, right? So that definitely need. I see some kind of disparity between two different kind of security models here, actually.
Yeah, there's really good points, because with the private chain, as you mentioned, the number of nodes matter. Because if you lose control of more than 51% of your nodes, you're going to have a bad day. As well as, how do you kind of balance the choice of, do you go public and use a public platform, or do you consider private? And what should be some of the key considerations behind that?
Yeah, it just depends on your use case, right? It is a vulnerability to expose yourself by having a public blockchain, right? You have parties which might have negative intentions and who you don't know why they're there, and they have voting rights and they have power if it's a public blockchain. But let's say if I'm operating a private company and I don't need everyone to be party to my, privy to my discussions, because there's also a big issue of privacy in the blockchain, right? Anyone can see what transaction has been made. On Venmo, if you go and on Venmo, if I send money to someone for dinner, I can make it private and people have no idea what's going on. But let's say if I buy an NFT, people can associate my public ID with my public wallet address, and they can send me whatever they want to. And now this is money in my wallet, which I have to spend gas fees on to get it out. So people can send me messages, NFTs, which can be offensive, all these things, just because someone's public address is, it's public. Anyone can send it. And that's where private blockchains are really useful, because if your use case doesn't need, everyone to be party to it, you can have a couple of key stakeholders, and you can use them to still get consensus, to still get some form of decentralization without opening yourself to the risks of being truly public.
Yeah, I would add sort of this public versus private scenario, thinking about, it's a buzzword, but zero trust, right, architecture. It's a thought process, right? So if I'm thinking about who needs access to my data, because cybersecurity and security, privacy, it all comes down to data. What do I have to protect? Who do I need to protect it from? Who needs access to it? And that's really where zero trust comes from. So I would say considering zero trust principles when you're making that decision, all about where your data is going to go, who's going to have access, and ultimately who can leverage that data. So that's what I would think about.
Great. Yeah, I want to push a little bit back for the privacy, private blockchain necessarily better for privacy. We don't think so, right? I think the short answer is zero-knowledge proof, right? That's what we're building here, right? So there are ways you can build in, like, you have privacy in the public public blockchains. Basically, you showed it this transaction using zero-knowledge proof. I 100% agree with what you said, right? So you shouldn't, like, sending money over blockchain shouldn't, like, be kind of like sending money over Twitter. And actually, it's actually worse than sending money over Twitter, because if you think the blockchain is going to therefore stay, right, your financial history will be there forever, right? That's kind of a more like scary scenario. That's what basically we're trying to build to solve this problem. Basically, you have privacy on the public ledger, not only for sending money, also for smart contract executions, also for buying NFTs. So, for example, so I think one thing we have to kind of make it clear here is that, let's say, if you have a private blockchain, right? Let's say IBM, like Venmo, or all these permission places running the ledger, right? I don't see, it's kind of a mitigated problem, but still that doesn't solve the data privacy problem, because this data is still exposed to the runners, right? So in a sense that, let's say if you are a user of the blockchain, right, you are still giving, despite like other people don't know, you are still submitting your data to these node runners, right? I think in that sense, building privacy on a public blockchain using better like cutting edge technology, I think it's a more promising way. But, right, so the technology needs time to mature, right? So it's still kind of work in progress, yeah.
Yeah, so it's also interesting because while I agree, like zero knowledge proofs can be super helpful and allow us to store some data off chain, the biggest concern is when you have data that you want to share and you impose access control on it, where do you draw the line? Is that like, so if you have access control, who is defining who has access to what, and are you returning to a centralized system? So we have to keep decentralization in mind as well while specifying access control, because it'll be awesome to have access control on blockchain, right? If someone has highly privileged access, they're able to see more data than other people, but the question then becomes, is this still decentralized? And that's what we need to figure out.
Right, I think this is a very interesting, because I think people didn't quite realize so far is that using zero knowledge, you could build like access control, right? To which level and how exactly do that still need a bit like a practice and exploration. I can give you a concrete example here, right? So for example, like we're building a decentralized and private payment system, and then you have we call it shielded address. Basically, it's a public address. Well, it's never disclosed on chain, but you have this address. You can send like, for example, your friend some tokens using this address. And at the same time, we do one thing called selective disclosure, right? So basically, it has a notion called viewing keys, right? This is for audit purposes. So for example, if you want to do regulation compliance, you can submit the viewing keys to some like IRS or government officials. And if you're enterprise, you are doing like internal auditing, right? This is also quite important. Then you can submit a viewing keys to your auditing companies, so they can actually have the access, right? So I think these are, I think in the short answer is that I do think all these problems is solvable using technology, right? We just need to kind of work hard in the tech to solve these issues, yeah.
So that's actually a good segue for the next question, and Nikki, I'll have you lead off with this one. So right now, there's more than 80 countries that have privacy laws on the books that have varying degrees of impact on data and data sovereignty. So how do you balance the privacy law requirements with blockchain?
Yeah, it's an important space because I think we don't have privacy laws and protection everywhere, right? Like it's still a conversation that's ongoing for what we have now. So what I always hope, right, is that with the conversation around privacy and security is that it becomes a conversation earlier on, so we can adjust either laws and regulations or have those conversations before it becomes a big data breach or information sort of gets publicly disclosed without sort of any sort of privacy already in place. So just like we talk about security by design, it really has to be privacy by design. You have to think about it even before you're talking about integration. Like, well, what does privacy mean to us and maybe our consumers, our customers, and our users?
Yeah, I totally agree here. I think I just want to ask the audience, right? So I think there is a lot of privacy laws, that's true. There's GDPR, there's CCPA, right? Do you guys think these laws effectively improve your privacy, except have one more like cookie button to click, right? That's my biggest problem. I think here basically our stance is that privacy have to build from in the bottom layer. That's what we're building, right? The bottom layer itself, the internet, we need to re-architect the internet to build the Web3 version of the internet which have privacy baked in rather than add on. So that this is like her trust minimization principle. You should like using cryptography to make like people cannot violate your privacy, rather than giving like using like kind of like a, I mean using laws is important. Just like I think trust minimization is the best way to build privacy. Actually, that's my view.
Yeah, that's an interesting interesting point. Because one thing, sure, it's good to have zero knowledge proofs and stuff, but it's since everything is decentralized, it's transparent, anyone can see it, and it's immutable, right? So if something's on the blockchain, everyone's privy to it, and everyone is aware that this has happened. So something that I think Vitalik released earlier this year is soul-bound tokens. It's a new paper. It talks about soul-bound tokens, which are basically non-transferable NFTs. So some people are touting this as NFTs 2.0. These are really useful because, let's say if I have a college diploma, and my college bestows this upon me, I could sell this as if it's an NFT right now, right? And someone else can just buy that college diploma. But if it's a soul-bound token, I can't send it to someone. Now, this is useful from the point of verification, but it also raises a lot of privacy questions. And the question then becomes, what are you comfortable sharing to the whole world on a public ledger? Because soul-bound tokens can be really useful in places like any place where you have to, let's say, upload your passport or any ID. If I don't want to upload my verification status or my residency status for, let's say, for vaccines, for example, if I don't want to upload my whole medical history, but I just want to upload that one card, soul-bound tokens can just say that, all right, I'm vaccinated, instead of saying, this is where I got vaccinated, these are the people that vaccinated me, and all my information is public then. And if I want to go on a website which requires this information, let's say to attend this event, you had to go on a website, sign up, and upload your vaccination card. You don't need to do this. You can have a soul-bound token which represents that you have this information, and you can only share this information with services you really trust. So this is going to be an interesting chapter of privacy where you're sharing more, but you're also controlling what you share and who you share with. So I think this is going to open a pretty exciting phase.
Yeah, if I can tag on to that, because when I think privacy, I also think about social engineering, because the amount of privacy that you have of your data can inform the types of social engineering attacks that are targeted at specific people. So the amount of information that's out there can actually make spear phishing and social engineering attacks more advanced and be a bigger threat. So I always think about that too, is what information is now out there or that people can piece together to target specific people more seriously.
I think it definitely brings everybody back to that whole kind of fundamental concept of the privacy and security by design, especially when you think about it from GDPR, where in the EU, privacy is a fundamental human right. From that point of view, it's part of the Constitution. When you look at it in the US, it's pretty much considered a penumbra law, where it's derived from other parts of the law from that aspect of it. So how it's treated is going to be very important. So again, with like immutability, if you put the wrong information on the blockchain and right to be forgotten under GDPR, and somebody wants that information deleted, then what do you do? So I think going forward, regulators are keenly interested in that, and then segueing to what you just talked about, zero knowledge proofs. So cyber criminals are often early adopters of new technology from that point of view. So speaking of zero knowledge proofs, so we'll kind of get into it as far as what are some of the critical gaps in security today that have kind of resulted in asset losses and things like that?
Yeah, I can maybe take. So I think if you look at the existing cybersecurity attacks, right? So there are some potential way you can attack zero knowledge proofs, but existing situation, like almost all the token attacks basically happens on bridges, because that's kind of the single most vulnerable part of the entire Web3 systems, right? So I think I'm actually thinking like adopting more zero knowledge proof can partially make the security bridge harder, because simply kind of like less information disclosed, And for these hackers, it will be a little bit like harder to find the target, right? I think that's the thing. I think security is such a hard thing, right? It's just like many different aspects. There's the security by design, there's security by implementation. And if you look at things, right, so a lot of cases happens on implementation level, right? Despite we have a lot of design level stuff. Yeah.
Yeah. So I think the biggest vulnerability is us. We are humans, and we make a lot of mistakes, and we forget a lot of passwords, and we use the same passwords even though all the websites scream at us to not do this. And this is where the problem is basically rooted, right? What good is having a 12-word seed phrase to your wallet if you write it on a piece of paper and put it on your table? Anyone can see it. So humans are also susceptible to scams. People are falling for get-rich-quick schemes all the time. I think Squid Games, there was token for Squid Games which someone made, and the smart contract suggested that you can only sell that token if you earn some more tokens, which were like basically like a separate token you have to earn by playing a game. So everyone bought into this token, but you can't sell it until you make some progress in a certain game. So again, people are falling for dumb stuff all the time, and the problem here lies in the design, right? A lot of websites are designed, like people look at a nice full stack front end and they're like, oh, this is a good project, but no one's really doing their own research. So what we need is good information and smart contract auditing to figure out, all right, is this something that I can actually trust? The blue check mark on Twitter gives me proof that, all right, this is something this is the person who is authentic. This is the person they say they are, right? Like similar to that, I think we need security companies to step in and have auditing in place or something in place which gives us that blue check mark for the right projects. This has been checked, it has been reviewed, it is secure. I think that's where most of the security vulnerabilities I think can be solved in that one honeypot.
Yeah, to tie onto what you're saying, it's sort of like a reputation scorecard, right? Like, can I trust this domain? Yes or no? Or how well can I trust this domain? So yeah, some sort of trust verification. I think I spoke a little bit about this earlier, but the education base for the general users, right? People that need to understand what it is and what it means, because if you either as a company or as an individual decide to buy crypto or you decide to adopt blockchain technology, if you don't have the right understanding, it's really difficult to build in those security and privacy by design principles into what you're doing. So I think there should be more sort of education in the space, and I think this is where a really great blend of private partnerships and academic research institutions comes into place, because the more research that we have around this and understanding those potential security attacks, those potential privacy issues, and actually testing them out, I think will help inform some of those decisions for organizations.
Yeah, and just to add a small point to that, this space is so speculative, right? Like the Squid Games coin I was talking about went up by 23 million% over, I think, a weekend. So it's such a speculative place, and academia, we know, takes a lot of time. So we need humans have to learn to be more patient and be like, well, everything doesn't need to be a get-rich-quick scheme, and I can be patient with what I'm doing. Or does academia or the research we're doing need to speed up to account for the fact that a project can blow up in a weekend and absolutely crash the next? So like, how do you account for the speed?
Yeah, I just want to add a little bit. This is great. I feel like we also need to add like developer education in addition to user education, right? Like software best practice. So if you look at the existing attack right now, right? They're mostly not this sophisticated attack. So I think like not too long ago, there is an attack on Sushi Swap, right? So it's basically called a supply chain attack. You just hire a contractor front end, just like really not so high tech, just putting kind of like a honeypot or something like that, stealing your information by their front end code, right? This is not an attack on the security of the RSA encryption algorithms or like zero-knowledge proof schemes, right? I think these kind of attacks can be and should be protected by like security best practices for the practitioners.
Yeah, and Nikki and I were just discussing this right before this, where right now, if someone wants to make a change, let's say to Bitcoin Core, there are maintainers which have to review it. There's a new, I think it's called BIP, which has to, like Bitcoin Improvement Protocol, which has to go out. So let's say if something like Log4j happened to the Bitcoin Core repository, where one dependency just completely, opened up a massive vulnerability, these changes are really hard to fix on a decentralized platform because you have to get consensus and you have to roll it out. So, big companies, IBM, Google, whatever, they were able to work on this over the weekend, roll out a new fix, make it fine. But if you're dependent on a dependency which is broken, you are subjecting yourself to massive risk. So a way I know some companies are trying to solve this is by not using too many dependencies. But again, that's not a scalable way to develop. So yeah, the speed, the benefits we get with blockchain are often also make security really hard for us. So we need to find the right balance.
I think one thing really important for truly decentralized protocol, which is Bitcoin and Ethereum are pushing really hard, is client diversity, right? You have the same protocol, but you have different kind of team, like implementing the protocol using different client. I think in the ideal world, you have a lot of client diversity, so that by kind of a decentralized governance, this kind of thing can kind of level out. But I agree, there's still a long way to go, yeah.
Yeah, Nikki, did you want to add to that as well?
Yeah, well, when we were talking about this idea of like, you have something in a GitHub repo or you're using open source software, you're basically opening yourself up to open source software vulnerabilities and what that means, right? So the more dependencies you have, the more third parties that are involved, it adds complexity, which increases risk. So the more complex that the systems get, the more difficult it's going to be to secure them effectively. Because what happens, especially with like decentralization, is if it's fixed in one place, you can't guarantee that it's fixed in another. So you have to think about what risk management means across a decentralized sort of environment.
So I know we're close to the end of time, so what we'll do is I'll run down the line and have everybody kind of give 2 key takeaways, and then we'll wrap up. So Ayush, you want to start off?
2 key takeaways from this. I think the biggest one is, we have new stuff like zero-knowledge proofs coming in, but what we really need to work on is educating ourselves and educating developers that are working on this, on these tools. We need to figure out a good way to have that blue check mark on projects which are actually vetted by, security professionals. So we need to get that going. I think that's the biggest takeaway. And the second one is, just educate yourself.
Nikki?
Yeah, I would say threat modeling, again, I think it's going to be really important for anyone that's considering making this decision, right? Or thinking about what it means to their organization or to themselves. Like, what does this actually mean? And then taking that as a second takeaway and having it inform your risk management program, because your risk management program, at any organization, it's not just about security risk, it's about business risk, it's all different types of risk, right? And so is the integration of whatever blockchain technology you decide to use an acceptable risk? So I think that's just an important question.
Shumo, over to you.
Yeah, I think my first takeaway is that I think privacy should be baked in, built from the first principle rather than add-on, right? So like we should build a decentralized infrastructure like with privacy baked in. And second, my second big takeaway is that we should try to think about trust minimization principle and trying to improve the security in all the spectrums, from the protocol design to user education, to developer education, to security best practices. There's no kind of a single silver bullet can solve your security problem. Yeah.
And I would just add, education is definitely key, especially as DeFi, smart contracts, and everything take off. If you want to entertain conversation, sit your attorneys and your coders together. So part of it is not just how do you figure out does the contract represent the legalese, but also how do you train attorneys on recognizing does the code actually match the legal language of the contracts. So if you could join me in thanking my distinguished colleagues.
Thank you.